Welcome. In this video, I'm going to be going through the oscillation reaction pre-lab. When you click on the oscillation reaction part 1 assignment, what you will see in the upper right corner is PDF lab guide. You can also get to this through viewing the class files. So let's click on that. When you click on this, there will be lots of information on how to go about solving the calculations necessary for making the solutions. But if you scroll down to page 2, you'll come to this page. And we've seen some of these in lecture already, namely that the solution is composed of the solute plus the solvent. And that could be in grams or in milliliters or some combination. Also, there are 3 formulas that we have to represent concentration as percentages. The one that we'll mainly be using is this one here, but we'll also use the mass percent. In both cases, there's a different way to express these, and I'm going to show you that. You may want to use this formula or this form of this formula or this one, but you may also want to use this other one I'm going to show you. Let's do this for weight over volume percent, although it could be applied to weight over weight percent as well. If we have a weight over weight percent, then this is equal to the grams of solute divided by 100 milliliters of solution. So if I have a 5% NaCl solution, then that is equal to 5 grams of NaCl over 100 milliliters of solution. Whatever this number is, this number will be also, as long as you have set it up with 100 milliliters of solution in the denominator. Now, you can use this equation to solve for various parts of the equation. For example, if I gave you the percentage and didn't tell you how many grams there were, but I did tell you there was 25 milliliters of the solution, then you could solve for grams. Similarly, if I gave you the amount of solution and the grams, you could find the percent. So we can use this to solve for various numbers and variables within this equation. If you scroll on down, you will see a summary of the 4 solutions you will need to make in order for this lab to work. Now, each one of these solutions we're going to go through in detail, but I do want to make one quick change, and that's that this should be weight over weight percent, not weight over volume. Other than that, I think everything is correct. All of the information for each of the solutions is given in the synopsis, such as the total volume. You know that solution 1 will be 10 milliliters. You know that solution 2 will be 10 grams, even though it is a liquid solution. We can use the balance to measure the mass of a liquid. And solution 3 will be 15 milliliters, and 4 will be 5 milliliters. And then it tells you what's in each one of the solutions. Notice how in each solution, distilled water is used. And we'll go through that as we move through each one of these in detail. Before we do that, let's talk about some of the glassware you will have available to you to make these solutions. On the left, we have a beaker. A beaker is used in the chemistry lab not for measuring volumes most of the time, but for containing solutions. And that is what you will use it for in this lab. So although there are markings indicating various volumes on a beaker, it is not very precise. We have other instruments available to us to measure volumes, and that's what's shown here to the right. This first one is a burette, and a burette is similar to a graduated cylinder, except it's flips upside down. You can see that the numbers at the top are low and the numbers at the bottom are high, which is opposite of a graduated cylinder. So let's look at how we might measure this particular volume in a burette. Notice how there are 9 markings in between each one of the numbers. So we know that this volume is somewhere between 28 and 29 milliliters, but we can get more precise than that. We can actually say that this volume is between 28.8 and 28.9 milliliters by looking at the bottom of the meniscus, which is just above the 28.9 mark. So between 28.8 and 28.9 milliliters, and you can estimate that last decimal place. Or excuse me, you can estimate an additional decimal place. So you can say that it's 28.88 milliliters, for example. And in lab, we will go into more detail on how to use the burette to measure a volume, because you will need to use it to dispense a certain volume of a solution that is in it. Graduated cylinder is similar to a burette, except it's the numbers at the bottom are low and the numbers at the top are high for obvious reasons. When this contains more liquid, then the number indicating how much liquid it contains goes up. So these are the two instruments that we will use to measure volumes. We will also use the balance to measure mass for solution 2. All right, so if we look at solution 1 in detail, let's see what it contains. It contains 2.08% weight over volume malonic acid and 0.403% weight over volume manganese sulfate. Now, the way that you dispense the malonic acid is you're actually going to weigh this on a balance, because this is a solid powder. In number 1, you will calculate how much of this powder you need to weigh. The manganese sulfate, on the other hand, is actually a solution that we've put in a burette, and this solution is 1% weight over volume. Let's go through each one of these questions in detail. These questions are what you're going to be doing for this pre-lab. So this says to determine the grams of malonic acid present in 10 milliliters of a 2.08% mass over volume solution. So let's look at how we would set this up. Just as I mentioned earlier, you can use the setup that I talked about, where we have percentage on the left, we have milliliters on the bottom, and grams of solute here. That's going to be the grams of malonic acid. Now, this is the original setup of those equations, of those formulas. It's not the alternate one that I mentioned. So you will need to include that 100 at the end. And then you would just solve for grams of solute using basic algebra. And then that would tell you how much you need to weigh out in order to make this particular concentration with this particular volume. Now, number 2 works with the manganese sulfate. It's a very similar setup to this one here. So keep that in mind as you work through number 2. Number 3 says if manganese sulfate was a solid, we would be able to make the solution directly, just like we did for malonic acid. But manganese sulfate is not a solid, or it is, but it is found in the stockroom as a 1% solution. So we need to determine the volume of this 1% solution that contains the grams calculated in question 2. So again, you would use this type of setup here, where you have 1%, you have the grams, which is what you calculate in number 2, and then you need to find the milliliters that you would need to dispense out. And then for the lab procedure, you're going to put it all together. So this is one solution that contains multiple solutes. So you need to keep that in mind as you put this together and figure out how would you go in the lab and make this. You will have a graduated cylinder. You will have the manganese sulfate, which is in a burette. And then you will have the balances to weigh out the malonic acid. So how would you go about making this solution in the lab? Remembering that you have distilled water as well. So we have water that we can add up to, after you've added the volumes necessary for each one of these two, then you would add distilled water to complete and make this a final volume of 10 milliliters. Okay, solution 2, you have a small beaker available to you, and you have the potassium iodate and the balance. You also have distilled water that you can dispense into the beaker and weigh it out. I would recommend dispensing it very slowly so that you don't overshoot. But you know that the total mass of this solution needs to be 10 grams, so you need to have it on the balances as you're making it. Number 4 asks you to calculate the grams of potassium iodate that is going to be present in 10 grams of the solution. So you would set this up. Again, I'm going to X this out. This is weight over weight. So it's grams of solute over grams of solution times 100. So that equals the percent weight over weight. We have the percent. We know that we want it to be 5.41, so we have this number. We also have this number. That's 10 grams, so we need to find this number here. And then you need to figure out how you would make it in the lab, given what you have available to you. Solution 3, you will have a small beaker as well, but you will have the solutions needed in a burette. Now, this is a dilution problem. So let's go over how we would solve an example dilution problem. In any dilution problem, you need to use this equation. Either M or C, I'll write that differently. I'll just write M1V1 equals M2V2. You could also substitute in C1 or C2. I believe in lecture we teach it as C1V1 equals C2V2. It doesn't matter. It's just a letter indicating the concentration. You need to have 3 knowns and 1 unknown in order to solve a dilution problem. I do have 3 knowns in this case. I have 3 numbers. I have the desired solute concentration. That would be C2. I have the stock solute concentration. That is the stock solution that I'm provided in lab. That is C1. And I have the desired final volume, which is V2. And I need to figure out how much of the stock solution I need to dispense in order to make this solution the appropriate concentration. So this would be V1. I set this up like this, 5% times V1 equals 1% times V2, or V2, which is 150 milliliters. I take 150 times 1. You don't need to do anything with the percentages here, like adjust them to a decimal. You just leave them as percentages. 150 times 1, and then divide that by 5. And that gives me V1, which is 30 milliliters. So in order to make this solution, I would dispense 30 milliliters of the stock 5% NaCl solution into my beaker, and then I would add, so 30 milliliters of 5% NaCl, and then I would add to that 120 milliliters of water, distilled water, in order to make the final volume 150. So keep that in mind. Don't forget this step. It's very important. Back to solution 3. Again, we have the total volume we want. We have the desired final concentration, and we have the stock concentration. So you'd use those 3 numbers and then figure out how much of the stock solution you need to dispense and how much water you need to add in the end to bring it up to 15 milliliters. Solution 4 is very similar to solution 3. is also a dilution problem, and you would go about it the same way. Remember to write all this in your lab notebook, all of your calculations, and all of your procedures in your lab notebook as you complete the pre-lab. You will need to fill in to Chem 21 labs your answers for each one of these. There are 6 problems, so you'll fill in the answer for each one, just as you see on the lab guide itself. And then you will complete part 1, oscillation reaction. When you come into the lab, you will have your lab notebook filled out with all of the calculations, and you will be ready to go to make all of these solutions and then complete the reaction. I hope this tutorial was helpful, and best wishes as you complete the part 1 oscillation reaction.